Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Andrew. And Andrew, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Thank you for that, Andrew. So where do you go to school and what grade are you in?
I'm in 6th grade and I go to Pioneer Drive Elementary School.
Pioneer Drive. What is your mascot? The Pioneer Drive?
Like the Patriot.
Patriots. The
Yeah,
Patriots?
Patriot.
All
Yeah,
right.
the
I was wondering if it
Patriots.
might be like Panthers or something. I don't remember what Pioneer Drive was. So how is 6th grade going so far?
6th grade is going good. Yeah. I get everything we're doing, and especially the math. I'm really good at the math that we're doing.
Well, good. That's glad. That's nice to hear that you get everything that you're doing, and you especially like the math because you feel you're doing pretty well at that, right?
Yeah.
What are some of the things that you've done so far this year in math that you can remember?
I've done area of like squares. I've done area of triangles, which I'm doing right now. And
Okay.
that's really all I can remember.
Have you worked with percents at all?
Percents?
Yeah, like I had 80% of something. Have you worked with percents at all?
No, not yet.
What about fractions and decimals?
Fraction and decimals, yes. I've
Okay,
worked
well,
on
you
that.
know what? Since you haven't worked with percents, maybe we'll do one of those problems today, right?
Yeah.
All right. So how long have you been at Pioneer Drive?
For 6 years and a half.
Okay, so you've been pretty used to it, right?
Yeah.
And how far does that school go to, or does it end at 6th grade?
It ends at 6th grade.
So where do you think you'll be going to school next year, do you know?
Maybe Sierra High School.
All right, so Sierra Middle School or junior high school? Whatever.
Sierra
Okay.
Middle School.
Is there anything that you're looking forward to?
I'm looking forward to doing new math, and yeah, that's pretty much it.
All right, well, good. Well, you're going to be doing some new math, and we're going to do some math with you in a little bit. But before we get to any of that, let's first take a look at today's Math in the News. And there we go. We've got our little graphic right there for our 20th season on Do the Math. Did you know that we've been doing this for 20 years?
No, I haven't.
That's almost twice as long as you've been alive, isn't it? How old are you?
I'm 12 years old.
Almost. We'll get there
Almost.
pretty soon. All right, I'll be right back, okay?
Okay.
So this season, especially the last few weeks, we've been talking to some of the people that are involved behind the scenes with Do the Math, and we've had great opportunities to visit, first of all, some of the high school students and even younger involved with Do the Math and how they got involved with the program. Now we're going to go even deeper behind the scenes, and today we've got Janet Murphy. And how are you today, Janet?
Good. How are you guys doing?
Excellent. So what is your official role with the program?
My official title is Digital Media Specialist, and what I do is I program for KETN, which is 24/7 programming, all educational programming throughout the whole day and a whole night.
Okay, so Do the Math is only on for an hour a day, but there are times when there are
Archives.
archived programs being
Yes.
shown. So
Yes.
you take
So-
care of that also, right?
Yes. So this is what it looks like. Here's the Do the Math from last week. And here we are right here, this empty spot,
Okay.
because we are live.
Got
So
it.
that's what it says. And here's where the math comes in. It's an hour-long program before us. We are an hour-long section right here, starting at 4 p.m., ending at 5 p.m. Now at 5 p.m., I go into some science content, and this is the title for it, and it shows how long it is. Now it's 29 minutes long. Now I have to do everything in 30-minute and 60-minute blocks.
Okay.
So I will add PSAs and promos and fill all the way till 5 to 5:30, 5:30 to 6, 6 to 6:30. So
Okay,
that's,
so if you have to fill things, right?
Yes.
So it looks like it's 29 minutes, 11 seconds.
right,
So you've got 49 seconds you need to fill.
exactly.
And if a PSA is 30 seconds, you've still got 19 seconds.
That's right.
So how do you take care of things like that that are a little bit off and odd?
Some of the PSAs that I have are in the 30s. They're like we got 5, 10, 15, 20.
Okay.
And then and then I fill with the IDs. The IDs at the end give you that pad
Okay.
at the end.
So if you need a second or two or three,
Right,
that's when you put the ID up.
right.
How long have you been with Do the Math? So you are in charge of KETN,
Yes.
but how long have you been part of Do the Math, or is it the same amount of time?
Same amount of time, 7
Okay.
years. I worked at Channel 17 for about 30 years, and I've done audio, master control, and everything over there. And so I was able to teach the kids here audio, master control, and what they need to know. And it's now I'm just programming, and which is fantastic.
Okay, so you've been with the program for 7 years.
Yes.
And how have things evolved, let's say, since you
Oh.
started to what it is today?
Absolutely. I mean, we obviously went all HD, so we have to measure everything in a correct bit rate and correct size for all the videos and all the archive videos that we have. We had to upgrade, and so now we're multi-channeling and multitasking now, and I also program for the whole week instead of a day. So everything has been upgraded and is constantly being upgraded. And I've learned that in the past 30 years being in television, that it is constantly changing.
Okay. So you don't need to be here, or somebody doesn't need to be here all the time. You can program the station,
Correct.
and everything will run on time as long as everything is operating correctly.
That is correct.
Now, how often do you have to deal with things not going exactly the way you want?
It happens. We had some problems with some sizing issues, some bit rate issues. And we find out where they are, and then we resize them, reprogram them, and get them back into our library. And everything's been running pretty good so far. As far as our time clock is on the GPS time clock, so it's hooked in correctly. So like when we had the daylight savings time,
Okay.
it changed with it. So no one had to be here to adjust it.
Now, I know that you take care of Do the Math and everything else, but some of the things that we see during Do the Math, including the ocean and NASA and videos and stuff like that,
Yes.
you take care of all of that. So can you explain a
Yes.
little bit about how you get that and how that works?
Yes, I've found, and I know a lot of people that are with JPL and NASA and all that, but they actually have their own channel, and I find footage that is available that we can use. We are a PEG station, which stands for PEG.
Public
PEG's
education
Public
something?
Education Government
All right.
Channel. So anything we use is all freeware. But most of our stuff you can find on what we call California Streaming, which is a streaming service that we also offer.
Right, and being in a school, I, before Do the Math even, was
Right.
familiar with California streaming.
Absolutely, absolutely. And that's where we get most of our stuff. But I also want to show you that we do stream, and if people want to see the 24/7 streaming, it's ketn.viebit.com if they want to see our live streaming. So they can see us on Spectrum
Okay.
15, but they can also get us streaming 24/7. Not
Very
just
cool.
do the
and
math,
I'm sure
but the
there
whole
are a lot of
program.
kids that are like, hey, you know what, I want to check that out and see what that's
Yeah.
like. So, final thing, if a student was looking at this and they're like, hey, you know what, I like to be in that industry maybe and be behind the scenes, I don't want to be out front or something like that, and that looks pretty interesting, how does a student get into that?
Absolutely, just find absolutely a TV station.
Okay.
And you just say this is what I'm kind of interested in. I'd like to try it, and they do take interns, and they will show you around. They love giving tours. We loved giving tours to, the Girl Scouts, the Boy Scouts, and,
Right.
when I was at 17 and stuff, and even the Leaders in Life would come in here and they say, we kind of like this. It kind of gets a hook in you.
Yeah, there you go. Well, you know what? All it takes is one visit someplace, and
Yes.
that turns a lot of
Either
students
know or
into,
you don't
hey,
know.
that's what I would like to try.
Correct.
Well, Jan, it certainly was enjoyable coming back and learning a little bit more about what goes on behind the scenes.
Behind the scenes.
Right, programming, everything like that.
Yes.
And we hopefully will have you around for another 7 years as we continue to do the math.
Absolutely, and we'll keep growing like we do.
That's right. Well, as we celebrate our 20th season on Do the Math, more behind the scenes today with Janet Murphy, digital media specialist. Is that correct?
That's correct.
All right. We'll be back with more right after this.
Hi, we're out here at the Stockdale High School at the Biomedical Academy, and I'm with the teacher here, Mrs. Adamson. And so what exactly are we doing here today?
Well, Stockdale High School has been invited to participate in something called the Valley Fever Project. And it's a huge project, first of all. We partnered with CSUB, and the students in the biomedical pathway have the opportunity to do a bit of research that normal high school students might not get the opportunity to do.
All right, so what exactly research are you doing?
In Kern County, we have something called valley fever. This is a pathogen that can actually get people pretty sick. And what we're doing here at Stockdale is collecting samples from the soil throughout Kern County, and we're putting it on this mapping software called ArcGIS. And what this software allows us to do is over time map out where valley fever exists in our community.
All right, so you're kind of using some big language here. So like what you're saying a pathogen, what exactly can you define that for us and for the viewers?
In the case of valley fever, we're talking about a fungus.
So would that mean that valley fever is like a mushroom?
That's a really good question, and something that a lot of people don't understand is that fungus can actually be microscopic. So these are actually found deep in the soil, and they are spores. And we can't see them with the naked eye, and that's part of what makes them a little bit dangerous, is that they can move with the wind.
Why are you guys doing this? What's so important about mapping valley fever?
Valley fever isn't something that exists everywhere in the world. It's endemic to the Southwest United States, and in Kern County, we're particularly affected because of our climate, our soil structure, all of those things. This project, by involving students in something called citizen science, it allows just everyday people to get involved in something that kids might not be able to get involved with. Usually this type of research will be done by professionals, by someone with a PhD in a lab, but this project gives students the opportunity to be a part of the research process and go out there and test the soil around where they live, the parks where they play, all of that. But what's really cool about this process is that we are able to include the students here at Stockdale High School and other high schools in Kern County in a very, very complex procedure that essentially takes these spores from the soil and we extract something called DNA. And this is something that's very unique to every single living being out there. And we extract the DNA and we're able to see if that pathogen, remember the thing that causes us to get sick, if that exists where the sample was taken.
That's so interesting. So we have so much more to learn here at Stockdale High School, so I'm going to send it right back to you, Mike.
Thanks for that, Kiki, and we will visit with Stockdale High School in just a few moments. A reminder, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Next week, the 23rd of March, Donny Day, will be the final day for Do the Math this year as far as live broadcasting goes. And then during the rest of the school year and during the summer months, you'll still be able to see Do the Math because, as we just saw, Jen will be able to program those things in there, and we'll see a bunch of the programs during the year over the summer.
Right.
In studio from Pioneer Drive, we have 6th grader Andrew. And Andrew, everything has been going pretty well in 6th grade so far, right?
Yeah.
And you said you've been working on area of different figures and you're doing triangles now.
Yeah,
All
triangle.
right, let's take a look at the camera right here. And this is one of your problems, number 4. So you have a triangle, and it measures, they give us 2 measurements, 34 inches and 14 inches, but there are some different things on there. So it looks to be a square and a dashed line. So why don't you head over to the board? You and Scott are going to work on this. But if you could, explain why there's a dashed line, what that means, and what that little square down there means, if you know also.
I know what those mean.
All right, well then that's why Scott's right there to help you out.
All right, what do you know about this picture? Tell us what's going on here.
I know, first of all, you have to write area equals, then this, base, and times height.
Yeah. Anything else that goes along with that?
You have to replace these.
Okay, so hold on before we replace them. What if we have over here, I'm going to draw a little picture of something a little different that you said earlier that you had done before. You said you've already done the area of like a rectangle, right? So
Yeah.
if we have an area of this rectangle right here, let's say we're going to take the area, and this is 10 inches, and this is 4 inches. How do you find the area of this rectangle? Show me real quick.
You would see this is the base,
Uh-huh.
then you put the base right here,
Yeah.
then this is the height, and so you would multiply them together to get, and these two would create the area.
Uh-huh. And what is that area?
The area is 40 because 10 times 4 equals 40.
That's true. Now tell me a little bit about the units that you use in area. What kind of units did you have here in the measurements?
Inches.
Yeah, you got inches on the, we're just looking at the rectangle now. We're going to go back to the triangle in just a minute, right? So
Yeah.
you have 40 inches, and when you have the area, we're definitely
right.
going to use inches, but what
And
else?
squared.
There you go. Put that second power up there because we have square inches. So tell me what area is. What are we actually finding out? Are we finding out how long it is all the way around?
Yeah, we are.
No, that's the perimeter. I tricked you.
For-
What are we finding out for the area?
Like how big it is.
That's right. We're finding out the stuff on the inside, right? Okay.
Yeah.
So you found the area of this rectangle. Would you agree?
Yeah.
All right. So here we go. I'm going to draw a little extra piece here. Let's say that was straight. Okay. What is this shape over here that is on the bottom? What is this shape right here?
It's not a part of the rectangle? No?
Yeah, it is part of the rectangle.
yeah.
But if I was going to cut this rectangle in half, right, by drawing that line that's supposed to be straight, what would you call this little shape down here that's on the bottom part?
Like half.
Yeah,
Half is
but what's it
rectangle.
called? It's a triangle, right? Has 3
triangle,
sides.
yeah, triangle.
So if the area of the entire rectangle, the whole thing, is 40 square inches, what do you think the area of this triangle is right here, this area right here, if it's half of that?
20
Oh, good call. 20 inches.
squared.
And what about the area of this triangle up here?
20 inches squared.
Good for you. So you're on a roll here. You're doing well so far. Let's use this information that you have found out to find out the area of this triangle. If you were going to find out the area of just this triangle up here, you would multiply the base times the height, but you'd also have to take half of it. Would you agree?
Yeah.
You have to take half of it because it's only half of the shape. And so I'm going to change your formula over here just a little bit. Base and height is absolutely correct, but we're working with the triangle, so we also have to multiply that times 1/2, or we have to take half of your answer. So don't forget about that part. I didn't want you to go too far and think we're doing a rectangle, because we're not. We're doing a triangle, right? And so you have all the things you need, but you can't forget the half, because a triangle is really only half of a rectangle. Does that make sense to you?
Yeah.
All right, so we've learned something today. All right, let's go ahead and plug some numbers in. What is the base of the triangle you're looking at?
34 inches.
Good, so you can put that in there.
34.
Good, and what's the height?
14.
Okay, now how do you know 14 is the height? Not just because it's the only other number.
Because it's going upward like
That's
the side
right.
of the
And
line.
we asked you a little bit earlier about that little square. Do you know what that square means on the bottom corner there?
I
That
know.
little square right there means that this is a right angle. And the height always has to be from the top of the triangle all the way to the base, but it has to be at a right angle. Because you could draw a line here, right? And it would be longer. And you could draw a line here and it would be longer. And you could draw a line here and it would be even longer. But none of those are the height. We need the exact height, which goes from the top directly to the bottom. That's right,
Straight to the
straight
bottom.
down.
Straight to
And
the
the way
bottom.
you show it straight down is to have this little box right there. It means that it's a right angle, and it means it's actually the shortest distance from the top to the base. So that's why we're using the 14. Okay, go ahead and plug that in there. Just trying to give you a little background about what's going on. Good, 34 and 14, and what else do we need?
And we need
That's right,
Yeah.
don't forget the half. We don't want to forget
the
that part.
half.
I love it how you write nice and big, because then we can see what you're doing really easily, and we can actually give you some more room. Okay, so when you are multiplying numbers, do you have to multiply them in order?
No.
No,
When you're
you
multiplying.
don't. You can switch them around, right?
Yeah,
So
you
for
can
instance,
switch
over
them
here, 2 times 3, what's that?
2 times 3 is 6.
That's 6. What about 3 times 2?
6. You
Yeah.
get the same answer.
That equals 6 also. So
Yeah.
you don't have to multiply these in order. If you want to, it's totally fine. Okay, so one way you could do it is 34 times 14. They give you a really big number. And then we can multiply times a half, or in other words, divide by 2. But
Yeah.
if you wanted to, right, if you wanted to, I'm just trying to give you a little hint to make it a little bit easier. Maybe you could just take half of 14.
Put a 2 right here.
Yeah, kind of divide by 2, right?
Yeah.
No, we don't want to multiply, we want to divide
Oh,
both
yeah.
of them by 2, right?
Not
Just
both of them.
one. Go ahead,
Okay.
can you use your eraser on that one? Yeah, that's important when you're multiplying. You don't want to do it to all the things, but you can divide 14 by 2, which is kind of a good idea, because
Only
that's
one
going to
thing,
give you a
yeah.
smaller number, right? So instead of multiplying this times a half, I'll cross that out. You're saying divide it by 2, which is a good idea. So what is 14 divided by 2?
7.
Good. And we still got to multiply that times.
34.
All right. So at least we made this a little bit smaller. And there's only 2 numbers left, which is a good thing too, right?
Yes.
Okay, what else do you want to do here? Oop, give you a little, sorry, give you a little more room there. 34 times 7, can you work that out for us real quick?
So,
In your head? Just
My
kidding.
head?
Just kidding. You can work it out. Go ahead, we want to see it.
so first I would break this number down, so like 7. 7 times 10, but 3 times, because it's 30.
Okay. Oh, so you're doing it piece by piece. That's a good idea.
Yeah. And then right here, I'd put 7 times 4.
Uh-huh. So you broke
7
up 30 into
times 4.
30 and or 34 into 30 and 4. Good job.
Yeah, so this would be 28.
Uh-huh.
And this 70 plus 70 equals 140.
Tell me what you're doing there with 70 plus 70.
So the answer for this, so this is 2, and then you need 3, so you add 1 more 70,
Oh,
and there you go 3.
okay.
140.
I love it when students bring some new ways of looking at it. This is a really good way to do it. I like this.
0, regroup to 1.
Yeah.
That's 1 left, and 210.
So 210 is that one. And another way to do it real quick, and you're going to add them together. Good for you. I like how you did that. Real quick, let's check this out. What is 7 times 3?
7 times 3 equals 21.
And then if you add a 0, you get 210. Look at that.
Yeah.
So it's another way to make sure that you're right. Okay, for your final answer, 210, I'll line it up here for you, plus 28. Can you add that together for me real quick?
0 plus 8 equals 8.
Yep.
1 plus 2 equals 3. And
Good.
2 plus 0 equals 2.
Gotcha. So that looks like the
2, 3.
area, except for
Except for you have to add,
the units, right?
yeah, the units.
Gotta have the units.
Units.
Tell me what units they are, though. We know what they are, right?
Oh yeah, feet.
I think they were inches.
Were they?
I think so. You want to go back up and see?
Yeah.
Okay, let's go see. I don't blame you
Oh,
for
wait,
wanting to
they're
check it out.
inches.
Oh, yeah, they are inches. Okay,
Inches.
so at least we got the right units. 238
Inches squared.
inches squared. And that's the area. And if you didn't multiply times the half, you'd have double that. But we want to make sure that half is in there. So that's the most important thing. Difference between rectangle and triangle. Triangle has half of the area.
Nicely done, man. You did take the 14, cut that into a smaller number. Something you might want to consider is take the bigger of the 2 numbers and cut that one in half so you have both of them a little bit more manageable. But anyway, nicely done on that first one. So you feel pretty good about that, Andrew?
Yeah, I feel pretty good.
Let me go ahead and erase that for you. We'll move on to another page. All right, you ready?
Yes.
All right, let's take a look at the next one. So we have another triangle. So
Ooh, that's a good
either
one.
one of you guys can draw that
You
up.
want to draw that one out for us?
Yeah.
Okay, let's see your triangle. Hopefully you can make your line straighter than mine. Shouldn't be hard to do.
So the base, I'll let you put the dashed line in there.
Oh yeah, make that nice and straight. Right down the middle,
Right
right?
from the
Okay.
top all the way down straight. And then put your right angle symbol in there.
Good. There you go.
So the bottom, the base, is 19 1/4 yards.
Yards.
Whoa.
This one won't be as difficult to cut in half, mentally maybe. The height is 9 1/2 yards.
All right.
9 1/2 yards.
And now
And now, he says,
Now.
for my next trick,
Hopefully you're going to get a little work with
Base
decimals
times
in here
height.
now.
base times height times what?
Times
Times?
1/2.
There you go. Don't forget that half. Well done.
A equals, the base goes first, so 19 1/4
Yeah,
times 9 1/2
yeah.
times 1/2.
Man, we got all kinds of numbers going on there. Now, do you want to keep all those numbers having fractions, or do you want to change them to decimals? Totally up to you. You can do it either way.
Change the decimal.
Okay. Do you know what 1/4 is in a decimal?
1/4 is, no.
Well, what's 1/4 of a dollar?
1/4 of a dollar is 25 cents.
That's it. So that's 0.25, right? So if you
0.25.
wanted to change that, you can make it into 19.25.
19.
Got to keep the whole number, right? Yeah, 0.25. That's 19 and 1/4. What about 9 1/2? What would you change that to?
9.50.
Good job. There you go.
5/10.
Yep. And then do you want to change the half into a decimal as well?
Yes.
Yes. He says, yes, the calculator likes decimals a whole lot better than it likes those fractions, right? Yeah, times 0.5. And you can put that 0 on the end. That's a great idea. You don't have to, though, because if you actually put it in a calculator, you might notice if you ever type in 9.50 in a calculator and you press one of the operation signs like multiplication or addition or subtraction, it will actually erase the 0 for you. It'll take it away. So it's not bad to have, but you don't have to have it. Just want to make sure you know. Okay, which numbers do you want to multiply together first?
The little number.
Or do you want to cut something in half and multiply two numbers
Yeah, you
instead
can cut
of
it
three
in half.
numbers?
That's right.
Oh yeah, we have to cut it in half. So
Yeah, it's same as multiplying times 5, so either way.
This, or, yeah, this one.
Well, that is the half. We don't want to cut the half in half.
Oh yeah, we don't.
So if you want to cut something in half, we can just take out the times 0.5 and divide something else by 2 if you want to. So you could take this one here and divide this by 2, or you could take this one and divide by 2, and that would
And
take
to
care
help
of
you
this
out,
part.
I'll use the calculator for this part.
Okay.
Okay.
So which one would you like
So
to
which
cut?
one you want to cut in half?
The bigger number.
The big one.
All right, so that's going to become 9.625.
Let me
9.
give you a little more room here. So right underneath there, 9.
6 to 5.
And what do we have to multiply that by to get our area?
9.50.
Yeah, that's it.
9 5/10.
Yeah.
9 times that by 5/10.
Now remember, this one right here ended up over here, right? That's what that one was.
Oh yeah, it was that.
So it's gone. So you don't have to do the 0.5 anymore. That was just a quicker way of doing it. Okay, now if you're really nice and give a big, big smile, we can probably have a little help with the calculator on that number too.
So
He says, nope, I'm not
he's
going to
gonna
smile,
do
I'm going
it.
to do it
Go
on my
ahead.
own.
I can.
I can do it. I like the attitude. Let's do it.
So can I actually have help?
You want a little help with this one?
Yeah.
All right, here we go. So it's going to be 91.4375.
91 4 3
And what's
That's
the
okay.
units?
yards
Yards. Good job.
squared.
Yeah, yards squared. Now, if the problem at the very beginning told you to round this answer, okay, you would have to shorten it up a little bit, right? So let's say I'm going to go ahead and make up one extra instruction for you. Can you round this answer to the nearest hundredth?
Hundredths.
Nearest
so
hundredth. What is the
this
hundredths place first of all?
Here?
No, that's
No.
the tenths.
It's the tens. Here.
No, that's the thousands. It's got to be in the between, right?
Yeah,
There you go.
in
Tenths,
between.
hundredths, thousands. So we're going to round the 3. That's it.
The 3. So that's higher than 5. So it become a 4.
Good job.
And the rest becomes 0.
And the rest becomes zeros. That's right.
yards.
Yeah. Can you fill in the rest?
Wait. Okay, so 4,
Yeah. Got a 4 there too.
1, 9.
Good job. So if you had to round to the nearest hundredth, you'd round this 3. I heard you say that the 7 is bigger than a 5, so it rounds it up to 4, and you'd had
Yeah.
91.44 square yards. And I think that's a
Square
good job on that problem there. Well done.
Great problem so far with the triangles, and for your efforts, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays. Just a reminder, next Wednesday, the 23rd of March, will be the last live broadcast for Do the Math for our 20th season this year. Right now we have another opportunity to go back out to Stockdale High School and visit with Kiki and find out a little more.
We are back at Stockdale High School at the Biomedical Academy, and today we are joined by Anne, Rashid, and Ekleen, and they're going to be talking to us about some of the amazing and funny looking machines that we have right here. So what's this first one right here?
Hi, so this is a Vortex Gene 2, and basically what this does is that we're going to put samples on top of it and it's going to shake the entire tube. And what that does is that when it shakes the tube, there's beads inside the tube that break open the cells, and once that happens, the DNA goes outside. So here, let me give you a quick example of what it looks like. So if we have a tube right here, we have beads inside the tube. So if we put it on here, we usually hold it for about maybe 10 seconds, and what that does is that it shakes the tube and it shakes the beads and it breaks open the cells, and we get the DNA.
All right, so you're talking about breaking up the DNA, or breaking up the cells. So once you have it like all mashed up, mixed together, how do you filter all that out? Is there a filter? Is there a chemical that you use?
So that's a good question. So what we use after is that we use the centrifuge.
A centrifuge is a machine that will basically spin around really quickly, create centrifugal force to basically separate DNA from the rest of the stuff inside the cell. And that will make it easier to use the DNA for stuff like DNA extraction or all kinds of gene stuff that you can do.
Perfect. So you guys are talking about the centrifuge. I assume that's this guy right here. I'm noticing a word on here that says RPM, and there's 10,000 of them. That's a really big number. So what exactly is an RPM? Can you tell me that?
So basically an RPM stands for rotations per minute, and what it means is that every time we put something inside and it spins, that's one rotation. So basically what this means is that it makes 10,000 rotations per minute. Yeah.
So can you show me like how you load the centrifuge? What does that look like?
So that's a good question. So the first thing we do is that we have one tube inside. This is our DNA sample, for example. We're going to put that inside,
and then we know that it's going at 10,000 RPM, so we know that's going very, very fast. In order to ensure that the tube doesn't go lopsided, we put one tube exactly on the opposite side of it. So if this one's in 3, it'll be in slot 9. What that happens is that when it's spinning at 10,000 RPMs, the tubes will balance each other out and the machine won't go out of control. So the force is equal on both sides of the machine, and because of that, the machine is able to spin properly and separate the DNA equally on both sides.
So what were to happen if it were unbalanced and lopsided like you're talking about?
In the situation that it were unbalanced, that would lead to problems, many problems especially. But one problem would be where if it's going at 10,000 RPM and the weight is significantly shifted to one side, that weight would trigger the machine to go out of control, and it could lead to like very bad consequences like explosions or issues with like the machine working in and of itself.
Wow, so you're saying that this tiny little machine spins so fast that it could fly like through a drywall, right?
Yeah.
Wow. Oh my goodness. So do you think that you guys can demonstrate like some of the forces that are going on in this machine?
Yeah.
I know that centrifugal force definitely plays a role.
it definitely does. So we're actually going to set this back down and we're going to actually start it. And then while that's loading, we're going to give you a quick demonstration of centrifugal force.
All right, so if we walk over here, Rashid's got a, what looks like a cup with some string attached.
Yep.
Right?
So we have a cup, and inside the cup we have some water. And initially you would think that if Rashid turns it upside down, the water would fall out, right? But the thing is, if Rashid spins it around, will the water actually stay inside, or would it fall out? And the right answer is that it stays inside due to this force called centrifugal force. And the same force is the force that we use inside the centrifuge. So if Rashid spins it, the water actually stays inside. And that's because there's a force pushing on the water, which makes it stick to the bottom of the cup, right? So yeah, so if we keep spinning it, we can count basically the RPM, rotations per minute, that we discussed before. So we count 1, 2, 3, 4, 5. So that's basically what RPM is.
Wow, that's a perfect demonstration. And I think I heard some beeping back over at the centrifuge. We should probably check that out and see what the results are.
So basically our centrifuge is done, and we can take out our samples, and we can see that the beads have settled to the bottom, and we can see that technically it would have separated due to densities and centrifugal force. And then now we're done with the centrifuge, and now we finished with the vortex in the centrifuge.
Perfect. Well, we have so much more going on at Stockdale that we can learn about, but for now I'm going to send it right back to you, Mike.
All right, thanks for that, Kiki. We appreciate the students especially and the staff at Stockdale High School also for allowing Do the Math and Kiki to head in there and find out exactly what's going on. 636-4357 is the phone number. Andrew is a 6th grade student from Pioneer Drive. And 6th grade, you've been there a little over 6 years, getting ready for junior high next year. Looking forward to all of the new math you're going to be doing, right?
Yeah.
All right, well, here comes some more new math for you today. All right. So let's take a look at the problem. This time you're going to still be working with triangles, but you're going to go backwards. So they're going to give you the total area, and they give you one of the measurements. You need to find the other one. So the base is 17 centimeters. So if you want to write that off on the side someplace. And under that you can put the area is 18.7 centimeters squared. And you need to find, well, I'll ask you, what do you need to find?
You need to find the height.
There you go.
Good job. All right, Andrew, what are you going to do here? And the first thing I'm going to suggest that you do is maybe even make yourself a little picture. Can you draw a picture of what this might look like?
What it might look like?
Yeah, what do you think this looks
It's
like?
the
It is a
base.
triangle, right?
Yes.
Okay,
Then 17.
there you go.
That's about 17.
Yeah, and then we don't know what the height is, right? So it could be a
Yeah.
really tall triangle, could be a really small triangle, or really short triangle anyway, but let's look at the number that's down here for the area, right?
Yeah.
These numbers are awfully close. Would you agree?
Yeah.
So 17 times 3 would be a really big number, like 51 or something like that. 17 times 2 would be 34. 17 times 1 is what?
17.
17. So how tall do you think that this triangle needs to be for us to go from 17 to 18?
I think it would be like a fraction maybe.
Well,
Like
it had to be at
point-
least 1, right?
At
Got to be
least
at least
one.
1, a little bit bigger than 1. But think about this. We also have that pesky 1/2 in there. Would you agree?
Yeah.
So if you had a value of height of, let's say it was 10, really what you'd be doing is multiplying times 5, right? So what value can we have for the height here? How high do you think this thing is? Right, we're going to have your dotted line here. Oops, that's kind of a crooked dotted line, but you know what I mean. Here's our dotted line for the height. How high do you think this is? If this was 1 times 17 is 17, pretty close, right? But what do you think it needs to be, just so we have an estimate of what you think this height needs to be to get it close to 17, or even just a little bit more? And it can't be 1 because you're going to take half of it.
So 1.3 maybe.
Yeah, 1.3, 1.4, maybe it could
Yeah.
even be 2, right? Because if you had 2 and you cut it in half, it would be 1, right? So
yeah.
just so you know, when we finally get an answer to this problem, we should be somewhere around 2, maybe a little bit more to give us 18.7, but that's just kind of an estimate, so we kind of have a little drawing of what's going on here. Okay, Andrew, tell me how we're going to solve this. Where are you going to go with this problem, and what are you going to do first?
So first, we're gonna maybe divide this. No, not divide.
I like how you're thinking about it first. It's important to think about what's happening there. And that's kind of what we did at the beginning. We had a good estimate. We thought about, this number needs to be somewhere around 2, maybe 3 to make sure that the answer is correct. Just don't know what it is. Well, you told me at the very beginning that this area formula is base times height times 1/2, right?
Yes.
Okay, so you already have the 1/2. We don't have to change that one, right?
Yeah.
And the base, we know that one is
17.
17, right? We
But
just
we
need
don't
that
have
height. So which two numbers can we multiply together that we know for sure?
7 and 1/2.
17 times 1/2, right?
17 times 1/2.
Can you multiply 17 times 1/2? Or in other words, do 17 divided by 2? Can you do that for me?
Yeah.
Okay, go ahead.
Divided by 1/2.
We want to multiply times 1/2, right? Not divide by 1/2. We want to multiply times 1/2. You can divide it by 2, which is the same thing.
And remember,
add a
it's
one.
17.
Yeah, we have 17, not 7,
There you
right?
go.
Oh, yeah, 17.
There you go.
Then divide by 1/2.
No, we want to divide by 2, right?
Divide
So
by
in other
2.
words, I was just saying, can you do this problem for me real quick? Can we do 17 divided by 2?
No, because it would make a fraction.
It would
Oh,
make
yeah.
a fraction, but that's all right. We can have a little decimal in there. We'll do, how about 17.0 divided by 2? We can do it that way too.
17 divided by 2, like 8.
Yeah, definitely. Let's put that 8. We want to put that 8 right over top of the 7 too, because it's going to be important to know what's going on here, right?
Yeah.
Got to make sure the decimal place is correct. There you go, the 8 right there.
Then now we go 1.
Yeah, and now
There's
you
one
bring down the
left
0, right?
Bring down 0.
Yeah,
10. And
good.
then 0.5.
That's it. And being messy is no problem at all. I love to tell my students, the messier you are, the harder I know you're working. So don't worry about the fact that your numbers went over top of your picture, because it just shows me that you're working on stuff. Nothing wrong with that. So it looks like the number that we have here, the base times 1/2, is 8.5.
8.5.
Now that number is not the height. I want to make sure you understand that, right? That number is not the height. That number just happens to be 17 times 1/2. So here's what we have. The area of the whole thing, do you remember what that number was?
The area of the whole thing was
18.7, right?
18.7.
So 18.7 equals, now we did 17 times 1/2, and what did you get? 8.5?
8.5.
8.5 times the height, right?
Yeah.
So we have one thing left to find.
The height.
Now, because we can't multiply it, what do you want to do?
divide maybe?
Yeah, let's divide it.
Divide.
So we can divide both sides by 8.5. Would you agree with that?
Yeah.
8.5. That gets rid of this part, and whatever answer you get will be the height. Do you want some help with that one? Yeah, there's a lot of decimals, huh? 18.7 divided by 8.5. Can we phone a friend?
What do you think it's about?
Well, we had a good guess earlier, didn't we?
So you had 2, right?
We had a good guess. Yeah, somewhere around 2. Because 2 times 8
It will end up
would be
at
about 16, right? So a little
16.
bit over 2.
2.2.
Aha, we were
2.2.
awfully close. Good job. Go ahead and put 2.2 in there for height, and then we have to make sure we come up with the correct units. Good. So that's pretty darn close to our guess, which is nice. At the very beginning, what units do we have?
Centimeters.
Centimeters. Can you put centimeters in there?
22. So there you go. 0.7 meters squared.
That was the area, and what's the
Yeah.
height?
The height is 2.2.
Equals, go ahead. 2.2 what?
Centimeters.
Good job. And not centimeters squared, right? Because that's not
Yeah,
the area.
because
That
that's
just
the
happens to be the
area.
height. Good for you. That's it. So through that work, and because we estimated at the beginning, we know that that number definitely meets up with our picture, right? Because it actually makes sense that, you know, it works out pretty well. If we got a number that was crazy big, like 17 or 18 or 24, we know, we probably have to go back and check that out a little bit. But this number works well with the model. Nice work.
And that's the importance of understanding the formula, knowing that reasoning through it, these two numbers need to equal that, and working backwards can help you with that. All right, well, you know what? As part of our 20th season this year, we have had the opportunity to have ROC and CTEC students produce entirely 100% all of the videos that you've been viewing this year. Here's another one, In the Day of a Medical Assistant.
I joined this program because I want to further my education in the medical field and become an RN, a registered nurse. Only seniors can take the medical assisting program, and I did that and I fell in love with it. And then so I decided to move on, and now I'm applying for nursing schools.
Well, this program is designed to help the student get an entry-level position as a medical assistant in a doctor's office or a clinic. The students learn hands-on skills to apply to the position in the doctor's office or the clinic, like vital signs, the chief complaints, EKGs, urine analysis, injections.
we do injections, we do take your blood pressure, your vitals, your respiratory, your pulse. We check your eyesight. Like basically, when you go to the doctor and you do like your basic checkup, that's normally what we do.
The most important way to use math in the medical assistant program is to calculate drug dosages, and they have to be accurate, of course.
So the vaccines that we study subcutaneous, we study intramuscular, we study intradermal. Those vaccines, we have to know the degrees, we have to know where to give them at on the patient. We do get tested on those vaccines. Usually we have to learn them in our pharmacology book too at the beginning when we don't start vaccines, but that's the main purpose that we study it. So that way when we get tested on the vaccines, we know where to give it. Over there are internships. You get to learn how to room the patient. You know, we get to learn how to file the patient's records, how to put their vitals in, and just be able to learn new things over there.
And once again, a big thanks to all of the staff and students at ROC and CTEC. We have been viewing excellent videos of theirs during this entire 20th season of Do the Math. And just once again, programming note, next Wednesday the 23rd will be the final live broadcast for Do the Math during our 20th season. Andrew is a 6th grade student at Pioneer Drive and has been working with triangles today, so how about one more problem? You ready?
Yeah.
Let's take a look at the graphic we have on the camera right now. This is the flag of Bosnia and Herzegovina, and they would like to know what the area of the triangle is, but it's not labeled in any way. So Scott's going to go ahead and put a rectangle up there.
The flag is waving in the wind.
And the entire bottom of the rectangle is 34 centimeters. And on the right-hand side, it says 17 centimeters. And now what you'll need to do is you'll need to draw yourself a triangle in there.
And it looks like...
And go from the other side, there you go, down to the corner. There you go. So up on the top, we've got 10 centimeters to the left of the triangle and 7 centimeters to the right of it.
And we want to know the top
you can
part.
probably leave the stars out, but you want to find the area of that triangle.
All right, Andrew, you better grab a pen, man. I'm going to need some help with this one. So first of all, what are the things you need to find the area of a triangle? Tell me one more time.
Need the center.
You need the base and the
times
height,
height.
right? But let's think about this first. You need the base and the height of the triangle, right?
Triangle, yeah.
So this 34, that number might help us, but that really is the base of this whole
Of the
entire
whole
rectangle,
rectangle.
right? We don't want that. Can you point to where the base is of this triangle, please?
Here, I think. Yeah, here.
Well, that number right there isn't even part of the triangle, right? We want a side that is part of the triangle.
Here.
That is definitely part of the triangle, and I would call that the height because that's how tall
height,
it is,
yeah.
right? So how tall is the triangle? What is the h value or the height?
17 centimeters.
17 centimeters. Now, what is the base? Can you point to the base? Where's the base of that triangle? That definitely is another number we need to use, but that's not part of the triangle, right?
So it's 34?
So why don't you go ahead and trace for me the triangle?
Trace the triangle?
Yeah, trace it. Right there, right there, right there. That's the triangle we're looking for, right? Good. So now you found the height, okay? And I'll go ahead and tell you right now that this is actually a right angle. You found the height, which is up and down right here. Which part is the base of that triangle?
Right here.
That's the one you want at the top part there, right? So we need to figure out what that number is, but we don't know what it is. So how are we going to figure it out?
I'm looking at this number by like dividing it a little bit because it isn't the whole thing.
It's not the whole thing. Yeah, how much is it? What is the whole thing, first of all?
10.
No, the whole thing from end to end.
From end to end is 34
That's
centimeters.
right. So how are you going to find the piece that we don't know, the piece that's in here? Which parts are you going to take away?
The 34 or 10.
You're going to take away 10, right? Because we don't want that part, right? We're going to take that part away. Which other part are you going to take away?
The 7.
That's it. You're not going to use that part because that's going to not be part of it either. So can you do that? 34 minus 10 minus 7?
34
Because that's really what we want.
that
Good.
equals 24.
Yeah.
And then minus 7.
And then 24 minus 7, right? Because we really want to know what that base is. Good. Got a little borrowing going on there?
17.
That's it. Okay, so can you now label the base for us real quick and just write it down so we know what number we're using? That's it. 17 centimeters. Good. So you now have the base, you now have the height, and you'll be able to find the area of this triangle. Just don't forget that 1/2, right?
No 1/2.
Okay, I'm going to stand here while you do the rest because I know you have all the pieces you need.
A equals base times height.
Good.
A equals
Put it in there so you don't forget.
17 times 17 times 1/2.
There you go. Good job. A little more room?
Yeah.
Okay.
First, I want to do this one. 17 times 17.
Okay.
17, this is 10, so I'll put it right here. That times 10 equals 170.
Good job.
And 170 times 7. So 170 plus 170.
Well, hold on. We're doing 17 times 7, right?
Yeah.
Yeah.
So you multiply
So you just got to do, you did 17 times 10. That was great. But we also do 17 times 7. Would you agree?
Yeah.
Yeah, there you go. So go ahead and you don't need to do the plus part yet. We got to do 17 times 7 next, right?
Yeah.
So let's see if we can figure that part.
Okay, so
There you go.
times 7.
Yeah. And you can get rid of the 0. It's not 170 yet. There you go. It's just 17 times 7.
17 times 7. 17 times 7. 17 times 4, and then 17 plus 3, and then that.
Well, how about just 17 times 7? What's 7 times 7?
7 times 7 equals
The whole thing's going to give you 289.
Okay.
289.
So when you do everything, it's going to come out to be 289. So you need to take half.
Yeah.
Of
170 plus 119 is 289. So 289 is the number we have, but don't forget that 1/2. We got to divide by 2. Can you do that for me?
Okay.
Okay.
So 200.
Good.
First I do 200.
Hold on, you're going a little quick there. Let's just
yeah.
go one at a time. 1
One.
times 2 is 2. We don't need these ones, right?
Yeah.
So can you erase those 2 zeros for me?
Right, so I'm going to let you guys keep working on that.
Okay.
While you're finishing that up, we're going to take our last visit out to Stockdale High School and visit with Kiki once again.
Thank you so much, Mike. We are back at the Stockdale High School with the Biomedical Academy, and this time we are joined by Mia, Ajuni, and Ria. And we have this funny little machine right here. Can you guys tell me a little bit about that?
Yes, this is Jello Electrophoresis. It extracts the DNA. After the DNA has been extracted, the DNA is sorted by long and short strands. The shorter strands move faster than the longer strands. These have been previously cut by restriction enzymes in certain locations.
All right, so we also have another one set up over here with, it looks like it hasn't been, set up yet. So can you tell me about how sort the DNA, how you set that up, how you set the machine up?
Yeah, sure. So right here we have the Jello Electrophoresis, and right here we have a gel already pre-placed in it. And with that we have a buffer, which is like a liquid solution that's going to move the DNA actually, so we can look at the bands and the length to compare it to a positive and negative control. So we have wells made in the gel right here, and our DNA samples that we've extracted previously are going to be placed in there, as well as a positive and negative control. So we have a positive side and a negative side of the gel electrophoresis, so we can compare this to a magnet. The DNA is negatively charged, so it's going to move towards the positive side, and that's like a magnet. There's an attraction that's going to pull it towards there, so we can look at that band length. So right here we have a pipette, and we are going to place a fresh tip onto this. And from here we can extract the DNA sample and place it into the well, into the gel electrophoresis, just like that.
So that looks like a pretty tiny sample. Can you tell me exactly like how much you're putting in?
Sure. So the pipette is set to 12 microliters, so this is the amount of the extracted DNA that we're going to be placing into the wells.
All right, so I also see a poster up there that looks like the gel electrophoresis. Can you tell me like what this is describing here?
Right, so this is basically a Jello electrophoresis that's already completed. And so basically Jello electrophoresis kind of acts like a game of red light, green light. And so the electric current pushes these samples towards the positive side, and then we kind of compare it like an answer key. So as these samples move, their shorter DNA strands move longer distances, and the longer DNA strands move shorter distances. So we can compare this sample to the positive and negative controls. So the positive control has valley fever, and the negative control has water. So we can compare these samples, and we can see that this sample actually is positive for valley fever.
Wow, so that's such a great representation of how gel electrophoresis works. And Ms. Adamson, if you could join us over here. So we actually have a special gift for you. This is a Do the Math tile. It is a token of our thanks for letting us come out here today and talk about valley fever with you and the project that you have.
I'm honored.
So how can other schools get involved in this wonderful project that you guys are doing?
You know, part of citizen science is giving power to the people and empowering students to be passionate about science. With this project, we are just wrapping up our pilot year, which is really, really exciting. We are doing this obviously at Stockdale High School. East High School is also involved. Our hope is that over time, we can push this out to all the high schools in Kern County, which is really, really exciting because that's a lot of students involved. That's a lot of passion about science, and that's really why we're doing this.
Wow, so that's such a cool, it's so interesting. But thank you so much again, Stockdale High School and the Biomedical Academy. Sending it right back to you, Mike.
All right, thanks for that, Kiki. Thank you to Catherine and all of the students that helped take that information, put it all together, and especially a big thanks to Kiki, one of our producers here on Do the Math, who was at Stockdale High School as a student. That's one of her classes, and she was kind enough to share what goes on in that class at Stockdale High School. Nicely done by all, and especially Kiki for getting all that put together. In studio, I had Andrew, a 6th grade student from Pioneer Drive. Did you learn a little something today about triangles?
Yeah, I did.
Yeah, you did. Remember that 1/2?
No, 1/2.
Right, because you like to remember that base and height, but remember that 1/2 on there also. Did you have fun?
I had fun, yeah.
Excellent. That's what we wanted to hear. Just a reminder, we have phone tutors available until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.